So this is the closest binary search tree value. So you're given a root, and then what you want to do is you want to find out the smallest one that's close to the target. So it has to be the smallest one. So right over here. So you will start from here and then traverse left and right. Pretty much in order, post order, it doesn't matter. And every single node you compare with the target, and then find out the actual the difference, and then update your current minimum tree node value. So that would be pretty straightforward. It would be easier to just dive into the solution, and I will explain what happened. So I'm going to have a tree node. I'm going to call it result. That will store the actual node that is closest to the smallest. And I'm also going to store the min val. I mean, you can define as anything you want. And initially, I'm going to define the root, and then later I will return the actual the result, which is the closest one to a target. And then since this has to be an int, so I will say result.val, and the min val will be determined whether or not it's going to be the absolute between the root and then the target, right? So mass the absolute root.val minus target. Okay, then I just basically traverse the whole entire tree, pass by the root and also the target, and then public void dfx tree no double target. So the base case is going to be if the no equal to no, I will return. And then also I'm going and then the first thing I'm going to do is I traverse until the tree is all the way to the left. So no.left and then target, and then later on was basically find out the left side dfx no.right target, and then in between I'm going to calculate the actual difference, the min value, and also update my result. So if the absolute, so math, the absolute no.left minus target, if this is less than the min value, I'm immediately update this min value to the difference between the no.val minus target. In the meanwhile, I'm updating my current node equal to the node itself, right? The result equal to node. And then here's a scenario when the difference are the same. However, it has to be a smallest, right? And I'm going to just find out, is my current val is less than result.val. If this is true, I'm going to say result is equal to current node. So this is a condition to make sure you update the smallest one. So the tree can be in any order. It doesn't matter, the smallest has to go left, largest go right. It can be any order. So let me run it. Submit. Alright, so for the time and space, space is pretty much constant. Time, no question, you traverse every single node in the tree, so it's going to be all of them. Alright, see you.